So this is video number 2 for one of my students who's resitting her Maths GCSE next week on Monday and Wednesday. So I'm recording this on the 4th of November 2025, and this is one of the favouriteest parts of my job. It's one of those that I do in my own time, and I always say to students, look, send me questions of things you want some help on, because as I like to create content for people when I know there's somebody waiting for it. Otherwise I get caught up in house stuff and then I make a mess around the house, and then before I know it, it's lesson time and I'm having to clear up everywhere. So anyway, so this is intermediate level. So for intermediate level, it goes up to the equivalent of a grade. It is a grade B, is the highest grade. So this is grade B stuff. This is grade 5 stuff. So when we're solving an equation, basically we want everything on this side to be equal to everything on that side. Okay, in simple terms, that's what that equal sign means. And when we have an equation, it has a lot of power. And we have certain rules that we have to follow to make sure that we keep that power, and we follow the rules to make sure that when we're kind of working towards our solution, that we are following the rules of how equations actually work. I'm just kind of thinking about what I just said there. Do you know what? I'm going to move on, but you're right, but I'm just going to carry on. So when we're solving, what we want at the end is x equals something. That's what we're kind of aiming towards. What value of x would make everything on this side the same as what's on that side? Now, all I'm going to say to you is, keep it super simple. What can you see there? In as few words as you possibly can. Well, you've got a fraction added to another fraction, and you've been given the answer of another fraction. Okay, don't worry about the fact that you've got these x's and stuff in there. You're adding two fractions together. Now, whenever we've got something where we've got an equation, so we've got the x's in there, letters, whatever they are, we want to try and get rid of everything that's on the denominator first. So we're going to multiply through both sides by whatever it is we can see here. So the first step I would do, there's loads of ways of explaining this. There's loads of sort of ways of breaking it down. But first of all, on the left-hand side, we're dividing by a 5. So all I'm going to do is I'm going to say, let's multiply both sides by 5. And why do we do both sides? Because that equal sign has got a lot of power. We want to make sure that when we're manipulating and moving things around to make life easy for ourselves and to get that x on its own at the end, we still need to make sure that whatever we do to one side, we do to the other. So what we end up with here is, because we're multiplying this part by 5, that cancelled that bit out. So you're left with 2x minus 3 for that part. Okay. The next part is we're going to multiply this bit by 5. Okay, so let's just do that. 5 lots of. Don't worry about how much detail is there. Let's just say I've got to multiply that bit by 5. All right, don't worry about that bracket. just a random line I put there. And then remember, we have to do the same to both sides. So we multiply this by 5. So 5 lots of. Okay, so we're just doing that. We've got rid of that 5 under there. Okay. Now, is there anything we can simplify at the moment? Well, think about when we're multiplying two fractions together. A little tip is, just stick a 1. If you've got a whole number and you're multiplying it by another fraction, just stick a 1 underneath the whole number. And so we end up with, and I'm just going to write this down here, 2x minus 3 plus, and I'm going to keep that 5 outside there for now. So 5 lots of 11 is 55. 1 times 2 is 2. So I'm just going to leave that like that for now. Have I got x on its own? Nowhere near it, but that's okay. So what we're going to do is we're going to look at what we've actually got left here and say, well, okay, so I've still got a denominator in here, and Natalie said that if I've got a denominator and I'm trying to solve some kind of equation, we want to try and cancel out that denominator first. So, well, we've got rid of the 5, so we want to get rid of this 2. How do we cancel out a divide by 2? We multiply by 2. So again, I'm going to use the same colour pen that I used on the first bit. So we're going to multiply both sides by 2. Okay, so let's do that. So remember, we still have to do the multiplication to every term we've got here, every expression, every term. So we've got this whole thing here multiplied by 2. So we're just going to deal with that bit first. So 2 lots of 2x minus 3. This bit now, if we multiply this by 2, it cancels out that 2 there. So we end up with 5 lots of 4x plus 5, because we've cancelled, all that 2's done there is multiplied that by 2. Has cancelled that bit 2 out. So we're just left with whatever was there. And then, after the equal sign, we're multiplying this whole thing by 2, which means that divide by 2 is cancelled out. So we're left with 55. Now, what we could have done, there's nothing wrong with this at all. This is absolutely fine. What we could have done is said, well, actually, we're dividing by a 5 and we're also dividing by a 2 across this equation. Even though it's different terms, it doesn't matter. So instead of multiplying by 5 first and then 2 later on, well, what's multiplying by 5 and then multiplying by 2 the same as? Multiplying by 5 and then multiplying by 2. That's the same as multiplying by 10. So what we could have done is just multiplied all of this whole thing by 10 initially. And you'd have got rid of both of those fractions in that first go. Okay, I might do this afterwards just to show you. And just looking at this practically, it's 2 o'clock, I'm tutoring at 3:30, so I'll see how I go because I need to eat something soon. Right, so what have we got here and what can we do with it? Sometimes we don't know a method to go from the question to the answer. So we look at what we've got and think, well, what can I do to make that simpler? Or what have I learnt in maths that I can apply to what's in front of me? Those 2 questions that you're going to ask yourself in an exam situation are so powerful. Right, so we've already done this in a previous video. So if you're watching this independently, 2 lots of that means we multiply everything in that bracket by what's outside it. And we're going to do the same here and the same there, yeah? So 2 lots of 2x is 4x. 2 lots of minus 3 is minus 6. And then we've got plus 4 times this bracket. So we'll deal with this bit now. Don't worry about anything else. Just do this bit now. So we've got plus 5 times 4x. So look at the sign, both positive. 4 times 5, 20. And then the letter, there's no letter outside. We've only got that one in there, so that's just going to be a single x. Then we've got plus 5 times plus 5 plus 25 is equal to, nothing else to do on this side, 55. Okay. I'm just going to just double check now because I'm talking through it at the same time, but also looking at my laptop, which is behind. I'm just making sure that I've copied everything down correctly. Right then, we've now got a case of collecting like terms. So you've got, get the x's together. So you've got 24x. And then you've got a minus 6 and a plus 25. So plus 25, take away 6 is plus 19, is equal to 55. Oh yeah. Oh, looking a bit simpler now, isn't it? Right, need x on its own. If you've watched any of my videos, or you might have heard me talk about the dating game. So to get x on its own, it needs all its hangers on to go away. Yeah, it needs to be left on its own so it can have the line like to itself. So because the 24 and the x are attached to each other, they've got a bit of a thing going, right? Don't separate them until the end, all right? If there's a bit of a hanger on there that isn't attached to that x, it's just adding or subtracting, remove that 1 first. So how do we cancel out a plus 19? We take away 19. It's always about doing the opposite, doing the inverse. Okay, whatever you're used to understanding it as. So 55, take away 19. And again, just a quick reminder, I'm sure you can do that. It's 25, 35, 36. So 24x is equal to 36. Because I'm doing that out loud whilst also talking, I am just going to double check that I have done that correctly, because I have to do that. Yeah, it's not 36. That's fine. So now, this is where there's going to be tears. We're going to have to separate the 24 and the x. Now, what's that 24 doing to the x? No rude answers, please. It's multiplying it. So to cancel out that 24, we need to divide by 24. So we're going to divide by 24. So we end up with, I'm just going to make a bit more space there. So x is equal to 36 divided by 24. And just write it like that. Okay, can we simplify that at all? Well, if I divide top and bottom by 12, I end up with 3 over 2. Now, can I simplify that? Perhaps give it as a mixed number. That is equal to 1 and 1/2. Maths with a smile, as always. Now, what I'm actually going to do is I'm going to go through that question again. But I'm going to do it, rather than multiplying by 5 and then multiplying by 2, I'm going to do by those two numbers together multiplied, which is 10. Okay, so just bear with me a second. So I'm just going to write it again. 2x minus 3 over 5 plus 4x plus 5 over 2 equals 11 over 2. So just a quick reminder, when we're solving that, words are very important in maths. Basically, we are aiming for x equals something at the bottom. Okay, so, oh my goodness, what's going on here? Right, we've got some denominators. We've got two fractions adding together. To get x on its own, there's no denominators there, is there? It's just a single x. So to strip away everything, so give x on its own, first of all, we're going to multiply through by a number that gets rid of those denominators, the 5 and the 2. Now, best one to do is to say, well, actually 5 times 2 is 10. So we're going to multiply through. We haven't got to do by 2 again. You could do 5 times 2 is 10. Multiply it through by 2 is 20. Multiply both sides by 20. But you don't need to, okay? If you want to do another example, do that again. What you'll find is you'll still get to the same answer. It's just your numbers are a bit smaller, all right? Or your end answer will be the same, but the numbers at the end, you're going to end up with like a much bigger fraction than 36 over 24. It'll just be maybe 72 over 48 maybe, okay? There you go, try it, see what you get. All right then, so what we're going to do, we're going to multiply both sides by 10. Because that will cancel out the 5 and the 2. So let's do it. So 10 lots of, and I'm actually going to put this step in. Plus 10 lots of that. I am very much an advocate for doing little steps, especially when things get complicated, because you want to make sure that it's a lot of people think, oh yeah, but I can jump from there straight to here in one step. Okay, maybe you can, and that's good that you've got that skill. But when you're in an exam situation, you want to make sure that you put all your detail in, because you want to make sure that if you did make an avoidable error getting to here, otherwise you get no marks. So you want to make sure that each step is careful. Maths is all about as well detail, accuracy, and being careful with what you're doing. Right then, let's do a little bit of cancelling out then. So 10 divided by, so you're multiplying by 10, dividing by 5. So what's 10 divided by 5? That becomes a 2. Okay. What's 10 divided by 2? 5. So that becomes a 5. What's 10 divided by 2? That becomes a 5. Okay. So all I've done is I've looked at this 2x minus 3 and I've said, well, we're dividing by 5 and multiplying by 10. So if you were to do that on your calculator, well, multiply by 10, divide by 5 is the same as multiplying by 2. So we've now got 2 lots of 2x minus 3 plus 5 lots of 4x plus 5 equals 5 times 11, 55. Do you remember seeing that before? So we ended up with this one, didn't we? Yeah? So it's just that on that version, what we did is we multiplied by 5, then we multiplied that what we had left by 2. Multiplying by 10 gets you in the same place. So what we can do now is multiply everything in there. So what I'd like you to do now is multiply that through yourself and see what you get. Okay? I'm not going to talk through any more of this now. I'm just going to quickly just fill this in. That is meant to be a 3. I promise you. It's a 3 over 2. Get it on there. All right. Thank you very much. Any questions, please just come back to me. Bye.